This is the old plastic press. In the last update, we managed to get it to print etchings by reinforcing this wall up here and adding a larger gearbox. There's nothing wrong with it. It did get a bit out of hand. It's a little unoptimized for 3D printing, but it works. This is the plastic press version 2. This press manages to be stronger, easier to print. You can print it without using any wasted support material. All of this for less than 1 kilogram of filament. And you can still print it on your standard, Prusa Ender 3 style printers. And while the original design only lets you build a 6-inch wide press, through some optimization, now we can print an 8-inch wide press. And really, everything stays the same, but you just need to print some new rollers. So if you've got an Ender 3 style printer that can print up to 250 millimeters tall, you can get it done. Assembling the press is as simple as making a press sandwich. You just insert the rollers and then the other half of the press, and then screw it down, and then you got a working press. And because this is so simple, and if you wanted to upgrade to an 8-inch press, it's as simple as swapping out all of the rollers and then just reassembling it. And speaking of upgrades, while the original design worked for me, I wanted there to be a bit more support for when you're kind of feeding in the press bed and then just catching it out on the other side. So I designed a version with these extending wings. And so now it can support your press bed while you register your prints or you need to ink your prints. And that way you don't have to kind of hold your sandwich together and then run it through the press. And when you're done, you can fold the wings up to save space. It even makes this press portable. And so here I have a fully upgraded printing press that fits in a tote bag. Perfect for taking it on the go if I need to bring it for events or something like that. And because of the folding wing design, I made it so that this whole thing, the original frame was printable on an Ender 3 style printer, and now we can have all of this space, and still you can use your smaller printers to make it. I thought about designing the frame in one piece, but that would require you to have a 400 millimeter printer, which I do have, but that puts it out of the realm of accessibility for everyone else. And I really wanted this project to be the accessible 3D printed press. And because I didn't want to manage different inventories and stuff like that, I designed it so that it kind of slots in and it still uses the original press frame, but these can be just an additional add-on. And so if you decided you just wanted to buy the base press to get started printing right away, but then later down the road you decided you want to upgrade, you could print yourself an upgrade kit, which is really just a set of the wing frames and 4 more rollers to support the press bed. And everything else is exactly the same. It drops in, perfect replacement, smooth and easy. But unfortunately, if you have a 180 millimeter build volume 3D printer, you can't build this press, but you can build this press. I know in the past a lot of people have asked about it, and I've kind of had a weird way of saying if you kind of shrunk it down to like 81%, it would work. But now this is a dedicated version, so it can use the same hardware, and it's a bit more optimized for that smaller build volume. This press still can open up to be an inch tall for your 1-inch matrix, and it can support a 5-inch wide press bed. So even though it's not as powerful as the bigger ones, it's still plenty powerful for its size, and it can still get just about all the same things done. But of course, if you don't want to build your own, I do offer kits on my website if you live in the US. The kits include pretty much everything you need to assemble it and get started printing, and the whole thing is easy to assemble within about 30 minutes. In PLA, I've got versions in black, purple, green, blue, and pink. These are perfect if you plan to use it indoors, and you can occasionally take it outdoors if you're in the shade or in a cool area. I also offer versions made of ABS and ASA, which is more expensive because it uses more material and takes longer to print, but this version can be used outside and in the sun, and it won't warp from high heat like PLA does. Now, if you want to make your own, stick around, but first, I thought I'd print something on this press just to kind of show you all what it can do. To print this etching, let's start by soaking some paper. For pressure on this press, I usually kind of slide my copper plate underneath and I set it to the pressure where it's just barely above the copper plate and won't touch it. And then, at least for my felts, I just back it up like 3 rotations, get the felts in there, and then lower it back down to where it was before. Of course, this only works with me and my felts, but if you buy felts with your press, this might work for you too. For this print, I'm trying out Cranfield's Caligo Safe Wash etching ink. In concept, this sounds weird to have a water miscible ink with a very wet piece of paper, but I guess it works. And I'll admit, cranking an etching through doesn't feel as sturdy as cranking it through a normal metal press, but you know, there's no weird popping noises, it's not like creaking, assuming you greased the gears, and it works. Some of the lines aren't quite as crisp as I want them to be. I think maybe my paper was not blotted well enough and the water-soluble ink just made them a little fuzzy. I don't know. But, I mean, just look at that ink density. It got all of that ink. Nice rich blacks. And I use a piece of whiteboard as my press bed because it's really like dense and hard, and the smooth white surface of the whiteboard makes it really easy to clean afterwards when you kind of get straight ink on it. If you do print a lot of metal plates over time, you might start to get, like cut marks onto your press bed, and then when those cut marks kind of absorb the cleaner and the water, they do swell a little bit. So the whiteboard's not a forever solution if you're going to keep printing metal plates, and in that case I would recommend just upgrading to something like an aluminum plate for a press bed, because there's no weird like gearing with the bottom of the press bed. You could literally just go and buy an aluminum plate off of Amazon and then just drop it in as a replacement. So, how hard is it to build one of your own? Well, as far as hardware goes, you're going to need 2 5/16 by 3 inch threaded rods, 2 5/16 inch lock nuts, nylon lock nuts. I'm using 2 springs right here, but you don't have to have the springs, it's just a nice to have for me. And then you're going to need 4 screws so you can screw it down to a base. Speaking of bases, I'm using a 3/4 inch piece of MDF for mine, but you could use any piece of wood, or I have a 3D printable base, but it's not quite the same as this hefty piece of wood. I also include a PDF that kind of tells you where to drill your holes for which size press you're making. And so next you'll need a press bed, and I'm using a piece of whiteboard, which is basically a piece of hardboard with like a non-stick coating on one side. And as I mentioned earlier, you could also buy a plate of aluminum for like $15 on Amazon, and that works, even better. One new ingredient for this build is some skateboard grip tape. And so I've got the clear kind just because I think it looks better, but the black scratchy stuff you put on skateboards, it's that stuff. And then you'll need some super glue. I like using CA glue because it's fast and permanent. And then you'll also need some grease. It's just good general practice to grease anything that moves in your press, but if you're planning on printing etchings, it's especially important that you grease your bearing blocks. And then as far as tools and hardware goes, you're going to need a screwdriver so you can screw it down to the base. And then you're also going to need some sort of box cutter to cut your skateboard grip tape. You're also going to need a bit of 60 to 80 grit sandpaper to sand the rollers. And of course, if you plan to print etchings, you're going to need a set of etching felts. And make sure you get soft felts because, it's a little underpowered, so it struggles a bit with the stiff felts. As far as filaments go, I've had the best luck with PLA Plus from sunLu. That's just my go-to because it's kind of cheap. But I've also had good luck with ABS and ASA, but I prefer Polymaker because the smell doesn't give me a headache. But I have not had any luck with PETG. It's just a little bit too soft to kind of keep the stiffness needed to print etching. So a few settings when I'm printing, I use a 0.2mm layer height, and I have a 0.4mm nozzle, but I print with a 0.6mm line, so this gives my line a little bit extra squish, and it lets me print a little bit faster, and so I can get stronger prints, print faster, but I don't get the oozing that a 0.6mm nozzle gives me. You might have to tune your settings for that. You might have to print a little bit slower because you're going with a much higher flow rate. And so just know that my walls, when I say I print with 2 walls, that's really 1.2 millimeters thick. If I'm printing with 3 walls, it's 1.8 millimeters thick. So regardless of which press you build, there's going to be a few parts that you will always need to make. So first up is the press frame, and I'm going to print off 2 of these, and I'm just going to use 2 walls, 15% infill. There's been a few changes since the last one. Firstly is the bottom geometry right here. Instead of doing a full fillet across the bottom of this, now it kind of goes up at a steeper angle, and so this just kind of helps you get rid of some of the weirdness that happens when you try to print a fillet on its side. Looking at the underside, now there's no holes right here, and I got rid of the top holes. That way you have to do less retractions and it's less likely to fail on you. I will say sometimes these little tabs right here where the feet are, they'll kind of lift off the build plate, and so if you have yourself like a tab extension, sometimes using some little mouse ears or some tabs helps some build plate adhesion. You can also print with a brim, that also helps. And lastly with this thing, with the last press, I found that this spot right here where the bearing block meets the screw nut could use a little bit of reinforcement, and so I ended up doing a little bit of weird geometry on the inside, and so that way this area right here, it'll put some extra kind of perimeters at it. And so here you can see that it does get a little bit weird in the slicer, but this way you kind of get a solid block of plastic around these spots, and that'll help you just kind of get a much sturdier interaction right here. That way you don't have to mess with trying to make partial solid areas within your slicer. This way it just does it all for you magically. And I've tested it'll do this for Kira 5.8 and for Prusa Slicer 2.8. So after you've printed the press frame, you're going to need a gearbox cover and a gearbox mounting plate, and I use the same settings, 2 walls and 15% infill. There's a few changes with this. There's tighter tolerances so things fit a little bit more snug. You can see here now I have 2 indexing tabs instead of just 1, so it kind of helps you line things up a little bit better while that glue sets. And on the inside of the gearbox, I kind of have it recessed a little bit more. It looks a little bit weird, but it's for the best. You see, when printing this big kind of flat surface area, when it starts doing the top skin again, sometimes you'll get an excess bulge line across the side of your piece. Well, now I made this top shelf a little bit lower, so now it's in this chamfered area. So now when you print it, it doesn't make such a weird line across there. You get much cleaner looking prints, uses a little bit less material, but all the same indexing goodness. You're going to need to print yourself one of these little lock pins. This is actually the only part that hasn't changed since the first design. Pretty much just print it solid. Can't really go too wrong with this one. See the pressure knob. You're going to go ahead and print 3 of these because you need an extra one to help slide the first 2 on. And for this one, you're going to want to do 2 perimeters, 15% infill, but this time you want to do triangle infill. And so for this one, you can see right here, now it has a little open spot up here where your threaded rod can kind of get in there easily, and that'll help straighten your threaded rod so it's perpendicular to the knob, and then it starts biting in and kind of attaching itself. So this way it just helps alignment a lot better than the last version did. And then this one you want triangle infill because that'll give you a nice solid area right underneath where the screw starts. Sometimes when you do cubic, it misses that spot, and so if you over tighten it, it just kind of punches into the hollow cavity that is there. But this way, now it's supported all the way through, straight from the screw. For the handle, I just print this with 15% cubic infill, 2 perimeters, and now the handle's a lot longer, so you can get yourself a little bit more torque when you're cranking it. And now I have the handle kind of sitting straight up like this, so this way it sticks to the build plate. I know the last handle didn't quite stick to the build plate quite as easily, but now this one will. You might have to print this one diagonally if you have a smaller build plate. Next up are these gears, and so they print just like they did with the other press, standing up like this. This way they need no supports when you're printing them, although you probably want to use a brim so you can kind of secure them down. Infill wise, I like to use triangle infill because sometimes cubic kind of misses these thinner parts of the gears, but triangle kind of sends some reinforcement all the way through. 15% infill, but for this one I usually give it 3 or 4 walls. Usually when you're 3D printing gears, you want the teeth to be solid plastic. And so here we can see when you print with 3 walls, it'll make sure that these teeth are solid all the way through. Sometimes you can just do 4 walls to get a little bit of extra stability in those teeth. And in the last version, I printed this smaller gear solid, and I definitely still recommend that just because it sticks out the most with the press. So if you ever drop the press or you bump it weirdly, then you know this won't break. Next, you're going to need these 2 bed support rollers, and these ones I usually just print with 2 perimeters and 15% triangle infill. Cubic infill is bad because it kind of leaves you gapped areas, but with a triangle infill, it'll send these lines all the way through in a nice uniform kind of way. And usually that's strong enough to support all the pressure that it needs. If you do cubic, it might break. These are just 16mm rods, and so if you wanted to just get those or some like 5/8 inch dowel rods, you don't have to print these, you could just use those. If you're building the extending wings version, you're going to need to print off 4 of these. Next up, you're going to need to print the bottom roller. This is the 8-inch version. This prints in 1 part, no supports needed. Just kind of take it slow so it doesn't tip over. One thing about the 8-inch version is it kind of has this bowl shaped connector right here. I found that if it was just straight across, that kind of zigzag motion when it was doing the top surface was too much, and it would always peel it off the build plate. But since I'm making this weird bowl version, since this top layer starts off small and then gets bigger, that zigzagging motion isn't quite enough to rip it off the build plate. And so that's just one small optimization about that. But printed with a brim, this one I usually do 3 walls, 4 if I'm printing some for my customers, but you can get away with 3. And then 15% infill, you can get away with it. If you want it to be extra strong, hit it with 20. Next up is the top roller, and I did include the files to print it in one solid piece. For that, you're just going to need to use some supports. Make sure you have some extra top and bottom layers to kind of reinforce this connector right here. And for this, usually I print it with 3 walls, 15% infill, and that's enough to get me to print some etchings. But of course, you can print it with more walls and more infill if you want a stronger press. But I don't actually recommend printing it this way. If you're going to print the top roller, I actually recommend printing the split version. And so the split version prints it directly on the build plate. You don't need supports if your bridging settings are good enough to do that bottom part. And then it has 2 keys. And I really prefer printing it this way because then I've kind of get this reinforcement at this kind of intersection. This kind of part right here is where most of the pressure is kind of distributed. And instead of just having 3 walls right there, when we combine it with the keys, now we have 6 walls, selectively reinforcing the weakest area of this roller. And so we use up the same amount of plastic as if we printed it with supports, but instead of wasting that plastic, now we're distributing that plastic to reinforce the weakest parts of it. And so you just print these off, and then the hex parts slide into the tops and bottoms of this roller, super glue it in place, and that's how that works. Now if you're printing the extending wings version, you're going to need these left and right wing frames. And these things, I just print them with 2 walls and 15% cubic infill as normal. And then I just let my bridging take care of this. My bridging settings are good enough to do this, and I don't really find that I need supports. And then here on the bottom, because this part is slightly recessed, I have a little built-in support right here at the bottom, and so you're just going to peel that off. But don't worry that there is a gap between the 2 parts that's supposed to be there. And of course, if you're printing the extending wings upgrade, you're going to need 2 more straight roller connectors right here, and then you're going to need 2 of these ones with the tapered ends. They're going to be called the roller connectors, and these you're just going to print with 2 walls and 15% infill, just like the other ones. Triangle infill, of course. You might have to print them one at a time. They're a little bit wobbly. And then for the nameplate, I just kind of print that solid, and then I have kind of like a pause at layer height for the top right before it does the letters. And that's how I get my 2 colored sort of nameplates. And that concludes the 3D printed parts. And once you've got all of your parts printed out, it's not quite time to put it together. There's a little bit of post-processing that we can do that kind of makes the press better in small ways. So the first thing I'm going to do is take the press frame, and since I print fast, I have a little bit of kind of buildup in this area right above this little hole right here. And this is where the press bed's going to slide back and forth a lot. And so generally it is best if this area is super smooth. That way we can kind of reduce the friction and reduce the wear on the side of the press bed. I think it's a pressure advance thing, but anyway, yeah, I'm going to remove the peaks from these little ridges. And pretty much anything along this top path, so this middle spot right here, if yours is already smooth out of the box, then don't worry about this. If you do ironing, I think it also removes this problem, but you know, something for the long run to do. Next up is this handle, and this little handle part is supposed to be like a captive spinning little handle, and so we need to break it free. And you just kind of wiggle it back and forth until it breaks free. If it doesn't break free, that's not the end of the world. And then once it is free, you'll definitely want to put a drop of oil or something down there, because it will be very squeaky if you don't. Next up, if you do the split rollers, is you need to put some glue and just pretty much just glue the little hex spot into the roller. There's little ridges on the side of the little, what I call hex keys. This is because it makes it a tighter fit. If it's too tight for you, you can always end up shaving it off. Next up, we need to sand the top and bottom rollers. We printed the rollers with a random Z-seam, so it kind of maintains a relatively uniform thickness all the way around. If you didn't, then you kind of get a little bit like one high spot on your roller, which it might interfere with pressure. So we're sanding off that Z-seam, and also it gives the rollers a little bit of texture, and that kind of helps it grip the whatever, your matrix and your press bed and stuff like that. Otherwise the PLA is too smooth, it has a hard time kind of moving everything when it can't get a grip on it. Anyway, once you're done sanding and you don't really feel the Z-seams bulging out on you, we're going to go ahead and attach the skateboard grip tape to the bottom roller. Make sure there's no dust left over on the bottom roller. And then go ahead and cut yourself a piece of the grip tape so it's more manageable to work with. It should at least be 6.5 inches long because it's a little bit more than the circumference of the bottom roller. And I'm going to try and center it as best I can, and then just kind of roll it about as straight on as I can. And then I'm just going to roll it up and kind of let the excess just kind of go over where I started. And then from here, I need to trim this down to be kind of an exact loop of the circumference of this bottom roller. I don't really want an overlap or a giant gap because that's going to mess with my pressure. And then I'm going to go ahead and try and make a crease right where this meets back up with the start of the grip tape. And so once I've got that crease, I'm going to go ahead and kind of use my box cutter and then make a slit right at that moment, and that's going to mark just kind of where I need to draw a line and cut this. So I'm going to unravel it a little bit so I have a little bit more space to work with, and then I'm going to kind of stick it down to my workspace, and then I'm going to put a ruler where those two slits are, and then just kind of continue the line between them. And with that, it should just line up exactly in a perfect circle, but if not, I can usually just trim off a little bit more. But this grip tape adhesive isn't perfect and it will come undone over time, and so usually what I do is peel back a little bit, throw in some super glue, and then just kind of super glue where the ends kind of land, and that ensures that it will not come unpeeled. I floated around the idea of applying the grip tape to the bottom of the press bed, which it does work, but I found that when I take my press bed off, it would scratch whatever surface I set it on, and it kind of left a lot of crumbs lying around. And so I found that this was a little bit better, and it also makes it so that you can replace the press bed a lot easier in case you lose the original or you want to upgrade to the aluminum plate. You don't have to reapply grip tape, and so it was just kind of easier for me to sell and tell people that they can replace their press bed later down the road. And you can use it without the grip tape, but you kind of need to push down in the middle of the press bed to kind of make sure that it gets good friction between the bed plate and the bottom roller. And so the next thing we need to prep are the pressure knobs. And so as I mentioned earlier, you need to print off 3 of them. 2 of them are going to be your actual pressure knobs, and then 1 of them just kind of helps you put the other one on. And I also find having some tape and some like ruler or calipers to help measure is going to be pretty handy. And so the cavity in the top of the 3D printed knob is only 15 millimeters, and so I'm going to measure myself off 15 millimeters on the end of this threaded rod, and then I'm going to mark it off with tape, so that way if I screw it in all the way up until the tape, I know that I have reached the end of the cavity and I should not screw in anymore. And so I'm going to take the unmarked part of my knob and then kind of loosely thread it into the waste knob, and then I'm going to go ahead and take the good knob, put a little bit of super glue in there, and then kind of get it started. And then I'm going to try and do this as fast as possible, but I'm going to kind of screw both knobs in until the good knob reaches the tape. So after that's done, I'm going to go ahead and see if I can remove the third knob. If not, then I'll just wait for the glue to settle, and then I should be able to unscrew the third knob. Just like that, we've made a threaded rod knob at like 1/4 the price of buying one at the hardware store. The next thing we should start is the gearbox, because it also needs glue and time to dry. And so go ahead, grab your gearbox cover and your 3 gears. You're gonna also need the gearbox mounting plate, and you're gonna want some grease. And so I prefer lithium red and tacky grease. I find that you don't need to grease it quite as often. It kind of stays where you need it to be. I've never had huge trouble with the gears kind of needing grease unless I print with ABS, but since we're going to seal up this gearbox forever, I think it's a good idea to apply some grease for it so we can be healthy in the long run. There's almost no such thing as too much grease for your gears, so I just loaded it up really rich. In the final design, I went with herringbone gears instead of these basic spur gears, but the process is the same. You're going to insert the small gear first, and then you're going to insert the middle gear, and then lastly you're going to insert this big gear at the end. And then over time, all of this grease will eventually kind of settle and kind of work its way into all of the cracks, so I wouldn't worry about it too much. And then I'm going to go ahead and start putting some glue on this thin rim of the gearbox cover, and then I'm going to snap this mounting plate into place. And there are 2 tabs for indexing. I usually put one side on first, and then I'll use these little pegs to kind of pull back and then down to kind of get that next one underneath the latch, and to hold the mounting plate in place while the glue settles. So you don't really need a clamp to hold it in place this time. For my own personal press, I ended up getting this clear resin printed gearbox cover from PCBWay. Not sponsored, but they did a really good job. It's super clear, and so I'm going to use a clear grease for this one that's not quite as good, but it lets me see the cool gears inside. So when the glue for the pressure knobs are dry, we're going to go ahead and install them into the press frame. And so to do that, I'm going to go ahead and grab it and just kind of cut my own threads into the top of this plastic here. It's a bit easier for 5/16 knobs. M8 knobs, it's a little bit tight, but if you have a tap and die set, you can probably just kind of cut your own little threaded teeth into there. But try to hold this about as perpendicular as you can. You don't want it to go in at an angle, and then just kind of thread it all the way through, and it's going to cut itself a path through it. And once you make it all the way out the other side, I'm usually gonna back it out so I can remove all of that plastic dust and debris out of the threaded rod, and then kind of lube it up a little bit, tiny bit of grease, and then send it back in. This will make it easier to operate once you're trying to change pressure from a daily basis, Next up, we're going to add the lock nut that kind of holds this bearing block in place. It'll also kind of give it a little bigger surface area to interface with the bearing block than just that small point of the screw. So I'm going to put this lock nut in that little cavity right there, and then I'm basically just going to thread the knob into it until it starts catching, and then it gets really tight to turn and I can't hold it in place anymore. So right about here is where finger strength is no longer strong enough to kind of hold the lock nut in place. And so I'm going to go ahead, grab a screwdriver, kind of jam it between the wall of the bearing block and one of the flat sides of the lock nut, and then just give it a little bit more of a churn to make sure it's securely on there. You don't want to keep churning too much to where the threaded rod kind of punches back out the other side and into the bearing block. And so just enough to make sure it's not going to wiggle loose during operation. Next up, if you have a spring, now's the time to put it in. So I'm going to open up the cavity a little bit, and then I'm just going to go ahead and slot a spring into there. It's got two little recesses to where you can kind of set it in place and it's not going to shift its way out of there. The purpose of the spring is to eliminate the tiny little bit of wobble that happens because of the clearances where the lock nut are. You know, that bearing block wiggles up and down just an ever so slight amount, but with the spring in there, it eliminates that wobble. You don't need the spring, you just need the threaded rod and the lock nut to really get this to work. On the side of the press frame, I've got these little marks right here, and this is a ruler in inches. Sorry metric friends, but if you use a 1/4 inch press bed, this will tell you the height from the roller from the press bed. And so, you know, I can set it right here. I'm setting it down to 1/4 inch, and then I can bring it all the way down to 0 if I make it to this last mark here. Let's start putting everything together now. So I'm going to take the base, and I already have my holes pre-drilled. You can consult to the PDF attached to the printables page to help you print off those holes. Make sure you don't scale the image so everything kind of stays true to size. And I'm just going to screw in one side of the frame for now. Make sure that the holes for the bed support rods are facing inward. And I'm going to sand my screws in at a little bit of an angle just because it makes it easier to reach since it does have that arm right directly above it. And then I'm going to set it on its side with the kind of the inside pointing up. And then I want to take some more of my grease, and I'm going to grease these kind of ends of the rollers where they kind of insert into these little bearing holes on the press frame. It's very important to grease these if you're going to print etchings. If you print relief, you probably never hear a squeak out of them, but when you're going through the pressures of etching, it's really important to reduce friction out of the system as best you can. And so the big roller goes in the top hole. I'm also going to grease the ends of the smaller bottom roller and then populate that one into the bottom hole, making sure that little hex hole is facing upward. If you're building the extending wings version, pause here and then jump forward to the extending wings version of the project. If you're just building the base press, we're going to add these bed support rods into these holes on the side. If you're feeling generous, you can spread some grease onto these little bed support rods, but honestly, they don't really need them since they're not really under that much of a load. And so if you don't have the extending wings upgrade, you're basically going to put the other half of the frame on here and then screw it down. Put a little bit of glue where the gearbox interfaces with these holes, and you're done. So now I'm going to go over the extending wings. And for the most part, it's going to be the same build process, but you could also add these wings after you've already made your press, and so we'll be talking about that too. And so here I have two sets of the extending wing frames, 2 roller connectors, and then 2 normal bed roller supports. And I also printed this little low profile screwdriver, which basically just accepts a normal 1/4 inch hex bit. It's just a low profile screwdriver because that screw area, it's going to get tight later. If you printed the extending wing frames yourself, you're going to have to remove this built-in support. If you bought it from me, I already did it for you. And so basically this little notch right here, we're going to go ahead and pry it off. And so you can use something flat. I'm using this ruler, or you can use a pair of pliers and just kind of rip it off. If you're starting with an already assembled press, go ahead and unscrew one half of the frame, preferably the side with the gearbox so it can lay flat on its side. And then we're going to remove these 2 bed support rollers here, and then we're going to go ahead and grab one set of the press frames, and so they should look mirrored of each other. And then go ahead with the whole sides facing up, slot them into the hole where the bed support rod used to be. They should be able to move in a 90-degree motion, just like this. Now I'm going to populate these holes with the bed support rods. First is the roller connectors, so the ones with the tapered ends, they go into the smallest holes, and then the normal bed support rods will go into the other 4 holes. Next, you can grab the other 2 wing frames and then just slide them over top all of these roller connectors. And once those are on, you should be able to just put on your frame and then screw it back down, and then that is an upgrade complete. This one's going to be a bit tougher to screw down, because of the added space from the extending wings, there's less clearance for your screwdriver to kind of get in there. I usually like to kind of hand place these screws in there, make sure that I get both sides started first, and then use my screwdriver to get it in there. And this is where the low profile screwdriver comes in handy, just in case your screwdriver can't reach in there. And if you're starting from scratch and haven't put your gearbox on yet, just put some glue in these 4 holes and a little bit around the gearbox hole, and then slide that gearbox on. It'll only fit one way, which is to the right, but after that glue dries, you're basically done. The handle just slides over this gear right here, and then the little lock pin can just slide over this little recessed area, and it just makes sure the handle doesn't slide off. Lastly, the nameplate can stick onto the side just like this if you're using 3/4 inch wood. Since I don't charge money for this design, all I ask is for a little bit of credit. And before we can print, we're going to need to set the pressure. And if you've never calibrated the pressure on a press, it's super simple, don't worry. So here I've lowered my top roller all the way down so it's touching my press bed. And then I'm going to take a pair of scissors, cut myself a strip of paper. This can just be cheap copy paper. And then I'm going to try and slide it underneath both sides. And I can't because it's touching the press bed. I'm going to back off the pressure little by little until it can slide underneath both sides. And then I'm going to tune it little by little. I'm trying to find the bare minimum height where I can slide the paper underneath, but it's not too high. And so I'm just going to open it up tiny bit, type by tiny bit until it slides through. And on the other side, I'm going to close it tiny bit, type by tiny bit until it can just barely pass through. And so I'm looking for the bare minimum gap on both sides to where the paper can slide through. And that's when I'll know that the top roller is level and I'll get them in sync. And so usually if you lower one side, it also barely lowers the other side. And so you have to go back and forth to find that sweet spot. But once the knobs are calibrated, your top roller should be parallel with the press bed. And so I'm going to go ahead and use some tape and mark the orientation of the knobs. And so here I'm just going to mark one little part of the knob, and that's just going to let me know where the knob's at in its rotation, and I can turn the knobs in sync and it'll help prevent it from being out of parallel again. One of the modifications you can do later down the road is making a really nice press bed. And so what I do for mine is I buy myself 8-inch thick piece of aluminum and then an 1/8-inch thick piece of plexiglass or acrylic. And then I just kind of have a piece of paper with this grid drawn onto it. I just use normal Sharpie markers. And then I just use packing tape on the end to just kind of tape it together in a sandwich. So now I get the lightweight portability of aluminum, the stiffness of metal, and the easy to cleanness of plexiglass, all while being able to see just kind of the grid of my press and being able to center things. All of the files that you need to make this press are available on my printables page, a link in the description. Go ahead and check it out. I also have a link to a manual that I'm kind of writing, and so that's just going to be a text form of all of the instructions that you need to print it, assembly, and eventually it's going to include my tips for using the press and maintenance, and just kind of a comprehensive everything you need to know about the press. But it's not quite finished, but it does have some helpful advice in it there. On the printables page, I also included step files, and so if you want to make modifications to make your press more suited for you, or if you wanted to make weird attachments for your press, it's much easier to do so. I look forward to seeing all of the weird, wacky things that you all kind of come up with. This project is free because I believe that printmaking should be accessible to anyone, and this is the most accessible way that I can kind of make printmaking. So if you've got a 3D printer, make yourself a press, make some prints, maybe tag me on Instagram at someprintdude, and let's see the cool things that you can make. If you don't have a 3D printer and you still want one and you live in the US, I do sell some on my website. Speaking of modifications, one of the things that people consistently seem to want is a wheel, and I gave it a shot. At 220 millimeter print beds, the wheel is so small that it just kind of is too small to work. It kind of gets weird. This was printed on a 400 millimeter print bed, and I guess it kind of looks cool, but it kind of blocks your hands from working on the press bed. And I don't really see a huge advantage, but it is pretty cool. I'll have to admit that. If for some reason that you want this, it's on the webpage. But personally, this makes this so unwieldy that it's not portable anymore. Before anyone asks if this can be made with longer rollers and wider press beds, I would say technically yes. If you add more perimeters and more infill, you can stretch it out quite a bit. But if you keep adding more perimeters and more infill, it starts to get pretty expensive. Eventually, you're going to reach a point where you're going to be using a full 1.5 roll of filament. Eventually, you're going to get to a point where you just spend like 2 kilograms of filament just to print a 1 foot wide top roller. And at that point, we're kind of approaching the territory of where it might be cheaper to start making things out of metal. Lastly, I wanted to say thank you to everyone who supported the first project, everyone who gave me feedback to help improve my design, and to everyone who bought one of my version 1 presses. I would never have continued this research and moved on to make this version 2 if no one was ever there to kind of support it and show interest. I probably would have just dropped the project. So thank you for showing your support. I did end up spending literal thousands of dollars researching this project, and I haven't quite broken even yet. But if you like this research and you do want to end up supporting me a little bit more, maybe funding some future research, I did set up a Buy Me a Coffee page. And so if you want to drop a couple of bucks to help ease the pain in between long research days, I would much appreciate it. As far as this project goes, I think this is probably a pretty solid and final version that I have for it. I don't know if I'm going to be making any big revisions to this press because it can kind of do everything that I want it to do. I do have goals for future presses. I might work on a 3D printed litho press or maybe an even bigger etching press. I haven't quite decided what the next one will be. So let me know down below which you would like to see first. I will say, because I think this is a pretty definitive and good design, this will probably be my last free design for this etching press. If I do decide to make bigger etching presses, I'll probably charge money for those plans so I don't send myself into debt over the idea of 3D printed presses. And so with that, I wish you all happy printing and happy 3D printing. I'll see you all in the next video.